move to the questions, please. Dear audience, please try to give questions. It's a very important opportunity to discuss contributions. One way to improve the quality of research, our research. So please ask. Questions, please. Okay, so my question to you, I have one question that you have.
Yes, yes.
How we can secure EOT communications without using, especially for security, without using encryption? Do you have any solution?
Yes, actually, I am still searching in this subject, and I found that there is a new technology used in for securing data, whatever in web transfer or EOT communications. It is about the blockchain technology. It is a technology that consists of using uh, an amount of data that can be shared with a secure key. Then we have Miner, I would say like the the concept of Bitcoin. It's based on the concept of Bitcoin. It's the block of data that are secured and that are that cannot be modified, and we have the integrity, we have the authentication. Yeah, we mean that the user should be authentified. It should be the data should be securized using key that are used only by the miner of the blockchain.
Okay. Especially when you talk about MQTT and co-op, and especially MQTT, what about using the token? Token, as you know, are more secured and based also on the encryption.
A token.
Yeah.
Yes, and who will possess the token to ensure the security? It's a shared token.
Yes, yes, you can share token to, for example, in order to communicate between two entities, we can use this solution.
Yeah, yeah, yeah. We can think about that. Yeah. Thank you.
Especially, I think, as I know, it's very used in IoT communications, especially when you talk about MQTT protocol.
Yeah, yeah, yeah. We're speaking about publisher and subscriber, so we can share a token.
Yes. So thank you very much. So we can
Thank
move to the
you.
next
Thank
for your
you.
presentation, Fatiha or Fathiya, sorry. I confused between those two names.
No problem. No problem.
Thank
Thank
you.
you.
So now we will move to paper ID. Carolina, are you here? Or AD? I hope that you solved the problem of your microphone. AD Vasquez. Carolina, can you hear us? Can you hear us? Carolina Soto Carrion. I see that you are the co-author of this paper, or co-author with AD Ambia. Yes, I don't know. I see that Mr. Edi Ambia has a problem with his microphone. I don't know if Carolina, can you present? Is it possible to present this? We cannot hear you, dear Ambia Vasquez. We cannot hear you. We can hear nothing. Nothing we can hear. Yes, nothing.
Sorry, Mr. The chair, but I think that he had to activate his mic in the second session. I think that he has two sessions.
Two session, you mean two? Yeah, okay. Yes. You use it to maybe you use your laptop or also you use your mobile. Can you turn off your microphone, please?
Now, please.
Yes, now we can hear you.
Okay, thank you very much. I gained my topic.
So you can share your presentation, please, Mr. Edi.
Hello. Good afternoon. My name is Edi Ambia Vasquez. It's honor for me to talk about design and construction of the experimental rocket UTEA-1 with the longest stable vertical range. Introduction. The purpose of the research has been to determine that the stability and vertical range of the rocket depends on the designs of the fins, number of fins, and the shape of the fuselage warhead. Sounding rockets are used to monitor atmospheric variables such as pressure, temperatures, and relative humidity. First, I go to talk about the pioneers. The Peruvian Pedro Paulet, 1874-1945, pioneer of the space age. The work of Paulet led a lasting legacy for the first scientists during the space. Accordingly, von Braun became director of NASA's Marshall Space Flight Center and the chief architect of the Saturn V launch vehicle, the super booster that would propel Americans to the moon age. According to Wernher von Braun, in world history, aeronautics, Paulet and Hoover in France warranted with to be considered the pioneer of the liquid fuel propulsion motor. Further, standing that by efforts, Paulet helped man reach the moon. The Russian Konstantin Tsiolkovsky, 1857-1935, father of cosmonautic. German Wernher von Braun, 1912 and 1977, precursor of space rocker. He oversaw the design of the Phi-2, the first long-range ballistic missile developed for warfare. The experimental designs. Okay, the second I go talk about the experimental. Experimental designs, what is done, they should be used. Experiments are used to study causal relationships, you manipulate or more independent variables and measures their effect on one or more dependent variables. There are 5 cases in designing an experiment. 1, considers your variables and how they are related. 2, write a specific textual hypothesis. 3. Designing experimental treatments to manipulate your independent variables. 4. Assign subjects to group between subjects or within subjects. Plan how you will measure your dependent variables. Now, this picture, can you see about the black box? Okay. Third, I got to talk about comparison of two processes, fermentation process and fry process. Why? Because in the fermentation process, now can you see numerical variables, a difference at the other fly process of the rocket, categorical and numeral variables. Design on the experimental rocket UTEA-1, can you see different parts the rockets? We proceed to select the three variables and their corresponding labels. For example, the categorical variables of fuselage was chosen in addition to 4 of fuselage were assigned, conical with blue tip and parabolic. Likewise, for the second variables, in this case, the fins were assigned two shapes, trapezoidal and delta. Unlike the third variables, in this case, it's numerical variables, were assigned 3 fins and 4 fins. Now, the software uses what's Minitab. With this statistical program, it was used to assist the treatments or experimental trials. And this picture, can you see experiment trials? For example, one assigning a letter A, okay, and tie on fins on the rocket, assigning the letter TA, and number of the fins, assigning the letter NA. All right, all A experiment trials. The experimental rocket UTEA-1 was designed and developed with 4 trapezoid fins with long nose cone because one test performed well. In this picture, can you see type of the fuselage nose cone, conical with blue tip. The type of fins on the rocket, this picture is trapezoidal. And number of fins, 4. Now, in the, this picture about the Pareto chart of the standardized effects. Now, a difference is the absolute value of the effect is displayed and reference line is drawn on the graph. That is, the bars that pass the vertical reference line are potentially important for the process under study. Okay. In this picture, the interaction between the factor and labels are equal. Therefore, there is no much difference in the aerodynamic stability between this factor according to the Pareto diagram. It gives us a clear reference that none of the 3 factors at their interaction are significant. The flight stability of the rocket is function of the location of the center of gravity relative to the center of pressures. That is to say, the center of gravity must be above the center of pressures and generally tend towards the center of the rocket structure to have a stable flight, and this is achieved by incorporation fins in the base of the rocket in a way that allows to increase the area of contact with the air and consequently decrease the center pressures. Now, conclusion. The stability and vertical range of the experimental rocker UTEA-1 does not strictly depend on the fins designs, number of fins on shape on the fuselage warheads. The stability of the rocker is directly related between the center of the pressures and the center of gravity of the rocket. The fins act as stabilized components and their effectiveness depends on their size, shapes, and number of the fins. The vertical range of the rocket flight depends on its power and the amount of propellant in the rocket motor. There was not much difference between the tests with the factor and levels of experimental designs and the prototype of the experimental rocket UTEA-1 with 4 trapezoidal type fins and blue-typed conical warhead has been designed for tests with good performance. Now, I hope you have understand my topic. Thank you for your time and attention.
Thank you very much, dear Ambia, for this nice presentation about a topic related to the design and giving an architecture for UTEA-1 in this paper. So we move to the questions. Please, if you have questions to Mr. Eddy, so you can ask, please. Questions, please. No question? Okay, I have just one question for you. Maybe I am far to this topic, but I have a question. I see that the objective of this UTEA-1 is to reach the high altitude, but also to have more stability. What about the energy consumption, especially for energy or power for the motor used in this engine in order to reach high altitude? There is any computing or algorithm used in order to optimize the energy consumption or efficiency here?
Well, and about the propellant solid, okay, it needs to the motor for the launch the rocket. And the altitude approximately 3,000 meters, but depends about the propellant solids. Okay.
Mm-hmm. So the altitude is about 1,000 meters, means 1 kilometer.
3 kilometers.
3, okay. Mm-hmm. And you provide the experiment because I see that you design and you construct a prototype, especially on your paper. You can see the prototype.
Yes, I construction about the prototype about the experimental rockets for these studies variables atmospheric.
So thank you very much, and we will move to the next presentation. Thank you, Mr. Eddy, for this nice topic and nice talk. Thank you.
Thank you.
Next presenter. Kanwal Zohor. Kanwal Zohor,
Yes,
can you? Yes.
Yes,
Can you please share your presentation?
All right, sir.
Perfect.
Did you see my presentation?
Not yet.
Okay, all right. Wait a minute. Now you can see my presentation.
Yes, perfect. You can go ahead, please.
Okay.